Hey everybody, this is the homework solutions for the simple circuits and the finding R equivalent. So the last homework for this week. Now the first question tells you that there are 3 amps flowing through the ammeter. So through this ammeter here, there are 3 amps. Now what you're supposed to know is that in series, the current is the same everywhere. So these 3 resistors are in series. That means each of these resistors is getting 3 amps. So I'm just going to write 3 amps. 3 amps, 3 amps next to each resistor. Now using only V equals IR, Ohm's law, you can quickly do in your head. I don't need to see work. You're just filling in the circuit. 3 amps times 10 ohms is 30 volts. 3 times 20 is 60 volts. And 3 times 30 is 90 volts. So you've basically, before you've done anything, you've filled in all the currents and voltages for your circuit right on the circuit. That's okay to do. I don't need to see work. It's fine. So going through the questions, the first question is what is the equivalent resistance? And you should know that in series, it's just the sum of the resistors. So this is pretty straightforward. 10 plus 20 plus 30 is 60 ohms. The next question is what is the voltage of the source? So now there's 2 ways you can do this. You could say the voltage of the source is equal to current coming from the source times the equivalent resistance, which would be 3 amps times 60 ohms, which would give you 180 volts. Or the other option is to say that the total voltage in series is the sum of the voltages. So that's just going to be 30 plus 60 plus 90 gives you 180 volts. So same answer twice. That was B or 2, I don't know. C was already answered. The current's the same everywhere. It's 3 amps. And number 4, I didn't even show any work. It's just on the circuit. You could show work if you need to, but I've already found the voltages for each. Now, question, sorry, I don't know if that's 4 or D. I don't have it in front of me. I think it's lettered. So question E says, which has the highest power? What you're supposed to know by now is that if power equals I squared R, and this is the same in series, then the bigger the R, the bigger the power. So you should, like some of you are doing work for all 3 to see which one has the biggest power. You're not supposed to do that. You're just supposed to know as R goes up, power goes up. So the answer for this one is 30 ohms. And then it says, what is that power? So that's the last question. Now, this is up to you. I don't know what you want to do. I just look at this circuit and I'm like, all right, I have the resistance, I have the current, and I have the voltage. So totally up to you what you want to use. You can do power equals I times V. You can do I squared R. You can do V squared over R. It doesn't matter. Personally, I'm just going to do power equals I times V because it doesn't have any squares or fractions. And I'm going to get 3 amps times 90 volts, and I get 270 watts. So that's the simple series circuit. It addresses all the concepts and math associated with a simple series circuit. Now we get to number 2. Number 2 tells us that there is, oops, I don't have it in front of me. Give me a second. 2 amps. There are 2 amps flowing through this ammeter, which means that there are 2 amps going through this resistor. Now, right away, I can quickly figure out that the voltage, without doing much work at all, just doing V equals IR, 2 times 20 is 40 volts on that resistor. What you're supposed to know about parallel is that the voltage is the same everywhere. So I can simply fill in 40 volts for this resistor, 40 volts for this resistor, and turns out the source is also 40 volts. This is only true if it's a simple parallel circuit, which is all we've done so far. But now that I know the voltage and the resistance, I can go back, fill in my circuit, and I know that I can find the current, which is just voltage divided by resistance. So this one is 4 amps, and this one is 1.33 amps. So I've already filled in a lot of the circuit before I even start to address the main question. The main questions are, A, what is the equivalent resistance? That's pretty straightforward. That's just 1 over 1 over 10 plus 1 over 20 plus 1 over 30, and that will give us 5.45 ohms. Question B, 40 volts. You already did it. Question C, already did it. All you did was I equals V over R for each. Filled it in on the chart. Again, I don't need to see work. You're just filling in the chart. Now D, my computer's making weird noises. D, there are two options. In parallel, the sum of the currents is the total current. That was from the notes you were supposed to take and from the activity you were supposed to do. So that's just summing each of the currents, which in this case is 4 amps plus 2 amps, 1.33 amps, and you get 7.33 amps. Another way to do it, if you wanted to, you could say the current from the source is equal to the voltage of the source divided by the equivalent resistance. So voltage of the source is 40. The total resistance of your circuit is 5.45 ohms, and you'll get 7.34 amps, which is basically the same thing. All right, E, already addressed it, 40 volts. F, now, what you're supposed to know about this one is power equals V squared over R. If the V is constant, then you should be able to see as the R decreases, the power increases. It's just a simple concept you're supposed to know. So that means that the 10 ohm resistor is the most powerful. And the last question, again, up to you. Do you want to do P equals IV, I squared R, or V squared over R? Up to you. You have all the information you need about this resistor. You have the resistance, the voltage, and the current. So again, I'm just doing P equals IV because it's the most straightforward. So I'm doing 4 amps times 40 volts, and I get 160 watts. That's a parallel circuit, combining all the concepts and math that you have to date when it comes to circuits. Now we're going to not do 3A because it's the easier of the two. We're going to go right to 3B. If you want to hear anything about 3A, then, I don't know, send me an email, see me during office hours. And let's get started on this one because this one's got a lot going on. So usually what I do is I look for things that are obviously in series. These are in series. That's 3 in series here. That's a 2 in series, 2 in series, because they're right next to each other. This is 3. This is 2. And now I'm looking for things that are parallel. So I see these two are in parallel because the current comes in at a junction, splits, and then rejoins here. So that's 1 over 1 plus 1 over 1, which is 1/2. And the same is true here. That's also 1/2. So now this circuit is looking a little messy. And some of you may know already, I'm just saying, some of you may know already that you could say that the 2 here and the 2 here are in parallel with each other and do that right away and not redraw the circuit. You may also see that the 1/2 here, the 1 and the 2 are parallel and not redraw the circuit and just do another side calculation. That's fine. For these solutions, I am simply just redrawing each step of the way. But if you're quicker than that, I got no problems with that. So I'm going to redraw this circuit. So what do we got going on here? We got a 3 up here. We got a 1 here and a 1/2 there. So it's a 3, a 1/2, and a 1. We have a 1 here, and then we got a split. A 1, a 2, a 2. We got a 3 over here. And then we have this shenanigans right here. We got a 1/2, a 1, and a 2. Sorry, squeezing that in there. A 1/2, a 1, and a 2. Okay, here we go. So these two are in series. That becomes a 1.5. That's pretty straightforward. These two are in parallel. That's 1 over 2 plus 1 over 2, which is 1. And then there's this whole thingy over here. Those three are in parallel with each other, and that'll be 1 over 1/2. Be careful with your math on that. For some reason, the fractions give some people some issues. And I believe that becomes 0.29, if I remember correctly. I hope, as I check my solutions, 0.29 ohms. Again, some of you may already see the next few steps and not want to redraw. You can see that this area is in series with itself, that the 1.5 and the 3 are in parallel, and you may want to do those. It's up to you if you feel like you need to redraw, but I am going to redraw for the sake of the homework solutions. So here we go, redrawn. Here we go. We have the, whoops, already screwed it up. We have the 3 and the 1.5. We now have the 1 and the 1, and the 0.29 and the 3 over here. So this is 0.29, this is 1 and 1, this is 3. So my next steps, these two are in series, that's a 2, these two in parallel, that's 1 over 3 plus 1 over 1.5 gives me 1. Again, some of you may see right away that the 3 and the 2 are in parallel to each other. And then afterwards, you're going to take whatever this region and the 3 and the 2 together and the 0.9, you're going to put them all in series. You may not have to redraw this whole thing. Again, fine with me. If you're getting the right answer, you're doing it right. I'm going to redraw, though. It's my job. And I'm going to screw up that drawing, apparently. Oh, no, that's okay. That's 1. And this is a 2. That's a 0.29. So 1, 2, 0.29, and this is a 3. So our next step is to combine, where did my 3 go? The 2 and the 3 in parallel, that's 1 over 2 plus 1 over 3 gives you 1.2. And again, many of you may see that the 1 here, this 1.2 that we've just combined, and the 0.29 are in series, and you may not have to redraw. I feel like a broken record, but I'm going to redraw. And there we go. We're down to our last bit. We have 1, 0.29, and 1.2. If you add those all together, because they're in series, you get, what do you get? 2.49 ohms. Yay! So anyway, that's the homework solutions for that. There's extra practice if you feel like you need it. If we ever go back to school, we'll be assessed on it. Maybe you'll want to save that for later and use it as a review when the time comes. But other than that, email me with questions, stop by for office hours if you have any questions, and I hope you're all well.